Let's say you're having one of those days. Maybe your coffee was cold. Maybe someone spoiled your favorite show. Maybe, just maybe, you have access to a nuclear device and a deep curiosity about how far you can push things. So, you decide, what would happen if I dropped a nuke into the center of the Earth? Now, let's assume you're not just tossing a bomb down a hole and hoping for the best. You have the tech, the funding, and apparently no sense of caution. You managed to drill 6,371 kilometers, that's nearly 4,000 miles, straight down to Earth's core. Not bad for a Tuesday. But before we push the big red button, let's take a quick look at what's down there. The Earth isn't just a hollow chocolate egg with gooey magma in the middle. It's layered like an onion or a nightmare lasagna. First, you dig through the crust, easy. Just rock, dirt, and a few angry moles. Then comes the mantle. A scorching ocean of solid yet squishy rock, heated to over 1,000 degrees. Finally, you reach the outer core, a 2,000 to 100-kilometer thick sea of molten iron and nickel, swirling violently around the solid inner core, which is a blazing hot, iron-rich ball roughly the size of the moon. Welcome to the center of the Earth. Temperature, about 5,400 C. Pressure, millions of atmospheres. It's not a place you pack snacks for. Now, you carefully lower your nuclear device, say, something on the scale of the Tsar Bomba, the most powerful nuclear weapon ever detonated. And then, you push the button. Boom. Well, kind of. But not the kind you're used to. At the surface, a nuke explodes with a brilliant flash and an iconic mushroom cloud, releasing energy outward. At the Earth's core, there's no room for dramatic visuals. Number air, no mushroom cloud, no Hollywood spectacle. Just unimaginable pressure crushing in from all sides. The explosion, while still powerful, is quickly overwhelmed. The core barely flinches. You might expect it to trigger an earth-shattering kaboom. But the reality is more like lighting a match underwater. The explosion's energy is smothered. It would create a momentary bubble in the liquid outer core, but the pressure would instantly collapse it. At best, you get a temporary seismic hiccup. The planet might burp, but it won't break. Still, all that energy has to go somewhere. Some of it radiates outward as seismic waves, giant underground shockwaves.